Hello, this is Dr. Lori. Welcome to this review of cross-sectional study designs. What I'd like to do here at the beginning is to put cross-sectional study designs along the continuum of what a lot of researchers think of in terms of the way study designs relate to each other. So what you'll see here is that we have cross-sectional study designs as part of the spectrum of observational studies. My pen is really, there we go, that's better. And so everything over here on the left-hand side of this line, these are all considered observational study designs. In other words, we are observing the kinds of exposures that people choose for themselves. I choose to eat blueberries for breakfast. I might choose specific things that I do in life. And so those are considered observational because I might choose my profession or I might choose certain things. And so we're just simply observing what is already happening out in the world for people. Experimental, on the other hand, means that the researcher assigns whatever exposures are happening. And so we'll get to that later in the quarter, but I wanted to give you the full spectrum of what we're going to be talking about, and also to kind of put the different study designs along this continuum. Now, some people might be wondering, what is this continuum? And so let me talk about that here really quickly. This is, for a lot of people, they would consider this to be sort of the level of evidence. And so those things over here on the left-hand side are not as strong of evidence towards looking at relationships between variables. And as we get over here on the right-hand side, these are considered to be stronger evidence of whatever it is that we're studying. So we really are kind of over here where we don't have as strong of evidence, but that's not necessarily a bad thing. Most people would consider the first two columns here, this part, to be hypothesis generating. And then once we get farther over on the right hand side, then these can be hypothesis testing. So we can actually test hypotheses. The reason that these lower levels of studies are hypothesis generating is because of the limitations that they naturally hold. So let's talk specifically about kind of a quick review of cross-sectional studies. An example of cross-sectional study would be like the YRBS, the Youth Risk Behavior Survey data that we've looked at already in this class previously. And Haynes is another good example of a cross-sectional study. And basically what we're doing is for different individuals, so for each person that we study, we are collecting information all at once. In other words, this is like a slice through time. We ask them a whole bunch of things about what is happening in their particular life. What do you eat? Tell us about your grades in school. Um, all of those kinds of things. And people are telling us about those on the day that we administer the survey. And so we are asking them questions that are all happening in that particular slice. So in other words, they're telling us about possible exposures and possible diseases or outcomes or all those kinds of things. All of that data is collected all at once. So that is the key feature of a cross-sectional study, that all the data is collected at once. A strength to that stems from the key feature. In other words, if you collect all the data at once, you can't lose track of these people. There's no loss to follow up. And so on any kind of a test, that's going to be the strength for a cross-sectional study. They are also, because we collect all the data at once and we don't have to follow them forward in time, we it can cost less. And so it can take less time, take less money, take fewer resources in order to collect this data. However, we're limited because all of the variables were collected all at once. We cannot establish a time sequence of events. In other words, we can't say that X caused Y because we don't know which one happened first. And so there's no ability to establish causation. There's a second problem that happens, and what I'd like to do is kind of draw this time sequence of events that I'm talking about. In other words, along this bottom axis is time. So in other words, if this is today, then yesterday was back here and tomorrow is over here somewhere. When I do a cross-sectional study, I collect both exposures and outcomes all at the same time. And I'm not trying to follow these people forward in time. I'm not trying to say, okay, well, let's collect data here and then come back a year from now and find out what happened. I'm not doing that. So what ends up happening is that as I'm collecting this information, I'm capturing people as they are today. And one of the problems that happens with that is something that once you can kind of see on this timeline, let's just imagine that I have like all of my individuals. Person number 1, 2, 3, 4, 5, 6, 7, 8. So now I'm kind of superimposing a new thing here. Let's say that person number 1 does not have whatever outcome that I'm looking at. Person number 2 that I could potentially study, maybe they had a very short case of it, but then they died. So they're not going to be part of my study. They died back here. Person number 3 also has this disease, but they have a really long case of it that's going to last a super long time, and so forth. If I were to draw where different people in my study have the disease or don't, so in this case 4 of the 8 people had whatever outcome I was looking for. If you can see that somebody who has a really short or quick version of that particular disease, if I do my study here, I'm not going to be as likely to catch people who have that disease for a very short time. I am, on the other hand, much more likely to catch cases that last a really, really, really long time. And by definition, the time that a person has the disease is often related to how severe it is. If a person is diagnosed with something and then dies really quickly, let's say pneumonia, then that was a really severe case of that particular disease. If somebody has a much milder form of it, maybe a different pathogen, or there's something else that's different about that, then they might end up having that disease for a much longer period of time before they get well. And so what we end up doing with cross-sectional studies is often we tend to include the milder cases of disease because of the fact that we are essentially collecting information in this cross-sectional manner. We tend to find people who have those milder diseases and capture them more frequently. Somebody who was an epidemiologist noticed this and they gave it a name. They called this late look bias. In screening, it's called length bias. It's also named Neiman bias. And so I'm giving you all these different names because it'll be called different things. And I've seen situations in the published literature where it was not screening, but it was still called length bias. And so you just need to be aware that people might not use this terminology really specifically. But the basic idea with late look bias is that since people with milder cases tend to live longer, or they have those milder cases for a longer period of time, we are more likely to catch them and include them in the study than people who have either a more severe case or a case where they die really quickly. And those diseases might actually be quite different from each other, those different kinds of expressions of, say, the same, what we call the same thing clinically. So that is an important limitation to these cross-sectional studies, late look bias. So I want you to include that. Another thing that we can see with these cross-sections, especially the large YRBS or NHANES, these large cross-sectional studies that happen. We are measuring individuals. I'm not saying that we are on the population level yet, but each person, the unit of measure, we're measuring an individual. We ask a specific person about things that are happening and specific outcomes that might also be happening for them. But what you may find is that we'll do, say, the NHANES in a particular year, and then we'll do the NHANES the following year, and then we'll do the NHANES again a year later. And so over and over and over, we're repeating this particular study. Now, the important thing to realize about this, let's say we did one in 2000, 2002, 2004. Different studies do this a little bit differently. But the important thing to realize about this is that each time that particular cross-sectional survey is conducted, different people are in the study. And so YRBS is all about high school students, the Youth Risk Behavior Survey. Well, 2 years from now, different kids are going to be in school, in high school. Some of them will have graduated, some of them will have come from middle school or junior high, and now they're high school students. So the group of students who are included in the YRBS in 2000 is a different group in 2002. They could be some of the same students, but the way they sample which high school they go to and that kind of thing, very often it's a completely different group of kids who are included. Same thing with NHANES. We may do that repeatedly over time, and that allows us to kind of see changes in the frequency of different risk factors, changes in the frequency of disease, but they're different people who we're studying over time. And so don't let that confuse you. Don't start thinking that all of a sudden this is now a longitudinal study, which is kind of more over here. So just because we repeat the study over time, a cross-sectional survey does not make it longitudinal. So that is my summary of cross-sectional study design. Thank you so much for joining me.